The Fixe Triplex removable bolts are some of my favorite bolts, and we tested them in sandstone, and we got some pretty interesting results because we tested 55 millimeters and 75 millimeters. Yes, these are both 75 millimeters, but we tested both, and we're going to show you what we got on this episode of How Not to Highline. Hi, I'm Ryan Jinks, and welcome to a Bolt Buster episode, where we're going to go into depth, on these Fixe Triplex bolts. Now, these take a 12 millimeter hole, and they take a very specific 12 millimeter drill bit, which you kind of got to play with, because if it's too big, it won't tighten. The wings don't engage enough, and the thing just spins inside the hole. And if it's too small, you're never going to get it back out. So, they're a little finicky in that regard, but I wanted to see, when I was testing things in sandstone, what happens when you use these bolts. Now, it is much better, at least in the highlining world, to use a glue-in bolt for sandstone. Now, I know that's not always common, but if you are going to use a bolt in sandstone that's a mechanical bolt, like these, you got to use long ones, and you'll see why in this episode. So all the tests are in shear, and the 55 millimeters that we tested, which is a little over 2 inches, I believe 2 1/4, doesn't give you 2 1/4 inches embedded in the rock. This 75 millimeter, or 3.25 inches, is only 3 inches embedded in the rock if you're lucky. And so 2 inches are embedded in the rock with the 55 millimeters. So, very interesting that they came out. Shocker. And they kind of destroyed the rock as they were coming out, which is really cool for the slow-mos. And the forces that we got were 27.3 kilonewtons, 25.54, and 33.02, which are technically strong enough. However, if you did cyclic loading, or if time wore them out, if it got wet and they were used while it was wet, it could compromise them. These were new holes and with new bolts. And so I don't know what time does. Put in the comments below what you think long-term would do to these kinds of bolts. But it was pretty hard to install them, because we had to actually pull on the Bolt Buster machine to 1 kilonewton in order to tighten the nut. Otherwise, they would just spin in the hole. And yes, we were using the right 12 millimeter bit. However, sandstone is, I don't know, made out of sand, and I guess it just didn't engage like it has for me in granite, which is where I normally use them. So then we tested 75 millimeter, or 3 inches embedded in the rock, and we got the nut. It nutted on us. The nut came off the threads, which is really interesting because the bolt did not come out, and it was pretty high at 41.5 kilonewtons. And then the other two bolts did come out at like almost double as the shorter ones. That extra inch just makes all the difference. 43.95 and 50.52 is pretty dang good for a removable bolt. And they came out, so technically they are removable. A fun fact, some bonus material in this episode, is some of our concrete tests, which we might do in a separate episode, depending on how much rabbit trailing we want to do. And we got 43.58, 39.66, and 35.24 in concrete, in shear, just like we tested in sandstone, which is interesting because we got pretty much higher in the sandstone. Very interesting in that regard. The tension, another interesting fact. These are just so interesting. Tension was basically the same as shear. That's also interesting. Tell me what you think about that. You can see all of this stuff on our Bolt Buster chart. You just go to the Bolt Buster chart on slackline.com and you hit Control F and you type in Triplex, and they'll all show up. And if you want to see every video, because we got lots of cameras on each of these tests, and you want to see something specific, you can go to the videos associated with them. Every folder is numbered, so you can see every brake test, it's super awesome if you are super bored. But if you're just sitting on the toilet watching this, let's bring up another interesting fact. Before I get into the facts, we're gonna have a discussion. Notice the hanger is below this flange. Now, if you don't know how this bolt works, I'm gonna take the nut off here, and this rod is tapered on the end, which pulls through the sleeve, expanding the cone, okay? So, if the hanger, which is what you clip to, is pulling on this, it's pulling the sleeve out of the rock, technically leaving the cone in the bottom. So, you tighten it before you use it, obviously. Is that a death wish? Okay? This requires a 1/2-inch hole in a hanger in order to do that, because that's a 12mm bolt. This one is the 3/8-inch hole hanger on top of the flange, pulling the rod up, leaving the sleeve in the rock. Okay, trying not to get too complicated here. Anyways, can you see the difference between this and this? This seems to make more sense, right? However, without really putting too much thought into it, I've always used it like this. Which one's right, you ask? Well, let me tell you. When we put the hanger below the flange, we got 40, 42, and 40 kilonewtons. And when we put it above the flange, the way you would think would be more correct, we got 43, which is higher, and then 39 and 35, which is lower. So basically it didn't matter. Please put in the comments below what you think, how these are supposed to be used, and why, since Bobby and I don't think ever came up with a conclusion for that.